Okay. So when we were back when we were calculating the area, we said we had if we used n rectangles, we had an area that was 1 over n squared times 0 plus 1 plus 2 plus all the way up to plus n minus 1, right?
Yeah.
And we were going to let n go to infinity. So that leaves us with this series, 0 plus 1 plus 2 plus 3 plus dot dot dot.
All the way up to infinity.
All the way up to infinity.
And if we add 1 to this, it becomes 1 plus 2 plus 3 all the way up to infinity. But we saw it equaled minus 112.
Right, we've seen from number file that this sums up to minus 112.
What?
Right, as we let n go to infinity.
Yeah.
So you were saying, well, for any finite number, it was n times n minus 1 over 2. But number file showed us when we go to infinitely many rectangles, suddenly it's not infinity minus 1 times infinity over 2.
It's minus
It's minus 112. Which would mean our area was what? Minus 112 divided by infinity squared.
Blah.
What's that going to be?
It's
going to be infinitely small.
Yeah.
It's surreal number.
Yeah, you're right. It is a good way to think about it as a surreal number. But is the area of our triangle infinitely small?
No.
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 It's just like 1/2.
Yeah, it's 1/2, and we don't need to go through all these weird infinite calculations to see it's a half, because as you go to set it, you could just flip it over, you get a square, and now you've got half a square.
So we don't have to go through infinite calculations.
But this calculation, that video on the internet, which must be true, right?
Yeah. Maybe
Because it's on the internet.
Maybe.
And it's also in the graph theory book or whatever they were using.
String theory, not graph
String theory.
Yeah. So anything's going on with this?
Something weird.
Something weird.
Things get weird when you go to infinity.
Yes, things get weird when you go to infinity. And that weirdness is what calculus is really about. Setting all these weird things that happen as you go to infinity.
The weird thing.
So I can show you it with these triangles, and everything works out just perfectly. Just perfectly.
Yeah.
With the area. And it all seems great, right? Everyone's happy.
Yeah.
But then I say the exact same argument doesn't work with the hypotenuse. And you'd think the hypotenuse would be easier because it's a line, not an area. And then we go back to our friends at number file who said, wait a minute, that series isn't n times n minus 1 over 2, or n minus 1 times n over 2, or whatever we said it was. It's minus 112. Uh-oh.
Boom.
Boom, yeah, heads explode. Alright, so that's our 3D printing and calculus. And we could have done the same sort of ideas with these, because you can see it's the same thing, we're just adding up
Cylinders.
volumes of cylinders.
And then we have those squares.
Yeah, we have these pyramids too, where we'd just be adding up squares to
That sort of
calculate.
reminds me of the 1/3 of a square of a cube pyramids.
Yeah, that's exactly
We
right.
also have Pac-Man.
And we also have Pac-Man. So, it's fun. It's actually neat to see how 3D printing can help you understand that basic calculus argument. And it's also fun to see how some of the other things that we've learned can help you say, well, wait a minute, sometimes that argument doesn't work.
Yeah.
So figuring out when they work and when they don't is really important. Anyway, good work this morning, guys. Good work.